So for number 8, this is missing, so I'm going to put that back in there. So it says graph the piecewise function. So if we graph the piecewise function, this should be together too. What I'm going to do is I'm going to find the spot where we have a piecewise function. So there's some stuff missing in this. So let's fix this. This should say f of x equals 2x plus 1 if x is greater than 1. F of x equals 4 if x is less than or equal to 1. So the magic spot, or the magic number, is 1. Okay, so I'm going to go ahead and label the axes. So I'm going 5 in each direction. And I'm going to put a light line where x equals positive 1, because that's where the graph gets split. Okay, so I did that. My next step is to graph both sides independently. Okay, so 1, I'm going to look at this line, 2x plus 1 equals f of x. Remember, f of x is y. So y equals 2x plus 1. This is a line. It's in mx plus b form. Your slope is 2 over 1. So remember, it's rise over run. So I'm going to go up 2 units and over to the right 1. Your b value, which you're going to graph first, is equal to 1. So that is a 0.01. Okay, so I'm looking, and remember that all my x values have to be greater than 1. Okay, so if I'm going to graph this, I'm going to start with the y-intercept, which is 0, 1. And then I am going to go up 2 and over 1. Okay, now this point is not included when x equals 1. So I'm going to put a little dot there, and I'm going to continue to go up 2, over to the right 1 unit. Okay, so my line would look like that, but I'm not going to include the stuff on the left-hand side of the graph, because if x is greater than 1, I need the right-hand side of the graph. Okay, so I'm going to include these 2 points. So this is what this looks like. And I'm going to make this really clear that that point is not included. Okay, all right. Now I'm also going to erase out that little y-intercept, because I couldn't use it because that was on the left-hand side of the graph. Now the left-hand side of the graph, x is less than or equal to 1. And for the second line, we have y equals 4. And I knew that because f of x equals 4. That is a horizontal line. And it's at y equaling 4. So if I'm going to graph that one, I'll do that in green. I find 4 where y equals 4. And I keep on graphing to the left of the magic spot. Let me get this out of here. Shoot, I'm going to have to redraw this really quick. Okay, and so I'm going to go all the way up to where x equals 1, and I'm going to include that point because it said that x has to be less than or equal to 1. So this is included. Okay, so there's your piecewise function, and let's look at 9. Find the average rate of change for the function between the two values. Basically, they're asking you to find the slope. Average rate of change means slope. So remember, the slope formula is y2 minus y1 over x2 minus x of 1. Okay. Unfortunately, you don't have the y values, but you do have x1 and x2. So we have to find the y values first. Okay, so I'm going to do the first one, which is x sub 1 equaling 2. So I'm going to plug that into my f of x. So I'm going to find the function at 2. So 3 times 2 cubed plus 2 squared minus 4. 2 cubed is 8. 8 times 3 is 24. plus 2 squared is 4 minus 4. So basically I get 24 here. And this is my y1 value. So I have my first point, 2 comma 24. Okay, and those again are x1, y1. Okay, the second point, x sub 2 equals 3. So plug that into the original value, the original function. So I'm going to find the function at 3. So 3 times 3 cubed plus 3 squared minus 4. Okay, 3 cubed is 3 times 3, which is 9. 9 times 3 is 27. And 27 times 3 will give me 81. Plus 3 squared, 9 minus 4. Okay, so 81 plus 9 is 90. Minus 4 will give me 86. Okay, so my second point is going to be 3 comma 86. Remember that that is x sub 2, y sub 2. Now I'm going to use the slope formula. So m equals y2 minus y1 over x2 minus x sub 1. y2 is 86 minus y1, 24, over x sub 2, which is 3, minus x sub 1, which is 2. Alright, so when I subtract those in the numerator, I'm going to get 62. I'm just double checking, make sure I don't make a mistake. And 3 minus 2 is 1. So the rate of change is positive 62. Alright. So that's how I do question number 9. For questions 10 through 14, graph the function, state the parent function, explain what type of transformation is happening to the parent function. Example is a parent functioning shifting to the left, up, down, or to the right. Did the parent function reflect over the x or y axis? Name all transformations that apply. Now I gave you a mnemonic device, Henry rents vehicles. So we're going to do horizontal shift first, then we're going to do any reflection, and then vertical shift is last. Okay? Alright, so let's look at this first one. Graph f of x equals the absolute value of negative x plus 4. The parent function is the absolute value of x. Okay, now I'm looking at this and I have a couple things going on here. First of all, I have a negative inside the absolute value. So I know I'm going to have to do something, and I also have the plus 4. Because the plus 4 is inside the absolute value, I have a horizontal shift. So I'm going to horizontally shift the square root of x's graph 4 units to the left. So that's the first thing I'm going to do. And then the second thing I'm going to do is take care of that negative, which is a reflection. So I'm going to reflect over the y-axis. And the reason why I'm reflecting over the y-axis is the negative is inside the absolute value. So I'm going to take the parent function, absolute value of x, and shift it 4 units to the left, and then reflect it over the y-axis. Okay, so let's do that. Alright, the parent function, just to remind everybody, it looks like a V, right? So that's what it looks like. Alright, so I'm going to take that function and I'm moving it 4 places to the left. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are all negative on the left. This is the x-axis. So, oops. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Okay, so when I shifted, I'm moving this graph here 4 places to the left. So where it was 0, it's now at -4 because I've moved it. And then I'm just going to graph it in. Okay, so this function at this point looks like this. So I did the horizontal shift. In blue. Okay, now I'm going to reflect. And I'm going to do that in red. Okay, so if you reflect over the y-axis, all of my y values basically become the opposite. So -4 becomes 0 becomes 0, right? So my x values actually change. So -4, 0, now I have 4, 0. And again, I'm doing this V shape here. Okay, so I'm just going to put a little note that we change the x value signs. Okay, all right, so that's it. And my answer is in red. I'm going to highlight it for you. Okay, 11. I'm going to actually start another video because it's going to go long otherwise, and we'll look at that in the next video.